Okay, so you may recognize these problems. They are the homework problems. And while homework is not due till next Sunday, the 1st, I'm giving you answers today. And yes, I realize you can just scan what you write down today and that'll be your homework. And I'm not going to count off for that. Homework, the purpose of homework is for you to practice the problem. So you know how to do the problem. So when you come across those same problems, well, similar versions of them, you'll know how to do them. If you choose not to do that practice, you've paid your money. So that's your decision. The gist of this is, after today, I will not give feedback on homework assignments. I will just check to see that you've done it and grade you accordingly. If you did it all, you'll get 100. Whether you got it right or wrong. I won't even check to see if you got it right or wrong, because you will have the answers at this point. You can check yourself. Now, if you come across something and you can't figure out how I got what I got, you're more than welcome to email me and ask me. I'm getting this. I don't know what I'm doing wrong. This is what I did. And I'll help you through it. I don't have a problem with that. I'm just saying that at this point, if you haven't turned in homework, chances are you will not receive feedback on the homework. If you have turned it in, you should have received some feedback. So let's get started. Let me start off with the problem solving chapter. And we start off with, out of 230 racers who started the marathon, 212 completed the race, 14 gave up, and 4 were disqualified. What percentage did not complete the marathon? Another thing is the formulas will be on the exam. So you don't have to memorize them. Just how to use them. You recall percent is equal to part over the whole times 100. So how many people did not complete the marathon? That's the part. What's the whole? 230 people raced times 100. And I get 7.83%. Please give me at least one decimal place, ideally 2. I got some 7s, I got some 8s, but we really should have some decimals. We should have at least 2, I would say, unless told otherwise. Next, we have a dress that regularly sells for $140. The sale price is $98. Find the relative change of the sale price from the regular price. So I don't just want the change, I want the relative change. Because the change is simply 140 minus 98, or 42. I had several people stop at that point. Remember, relative change was the change over the starting value. Technically, the absolute value of the change. So this will always be positive. So our change was $42. Our starting value was 140. And we want this as a percentage. So we're going to multiply that by 100. And we should get 30%. Any questions so far? Now, this next one, I don't think we did one like this in class. And I apologize because I meant to. So what's going on here? An article reports sales have grown by 30% this year. 30% of what? The previous year. And after that 30% growth, they're at 200 million. What were sales before the growth? So there we go. We want to know what the sales were last year. So let's assign it a variable. And we'll just stick with sales last year equals X. That works. Nice variable. Most common one used. What is 30% of X? I'm sorry? We don't know what X is. Remember what we said when doing calculations with percentages, we have to convert it to decimal. So 30% of X. Remember, this is basically saying multiply. So that is 0.30 times X. That makes sense? So last year, my sales were X. This year, they increased by 30%. So I'm adding to that, and I'm adding 30% of X. And that made it 200 million. Right? Now I have 1x, remember that's understood 1, plus 0.3x. So I have 1.3 times x equals 200 million. So now if I divide both sides by 1.3, and then I use my calculator, (200) divided by 1.3. And to 2 decimal places, I have 153.85 million. Any questions on that one? And remember what I said, the test comes from the homework. So any homework questions based on any test questions? Okay, I'll get you, Melanie. Thank you. Any test questions will be very similar to these homework questions. Sometimes they're the same one, depending on if I remember to change them. So if you can do this homework like it's a test, you should be able to do the test without a problem. You think that's funny, right? I did that in an algebra class once. I did the study guide. It was the test. We do the study guide 2 days before the test. The grades for that test were worse than any other time.
Yeah, I taught nursing students pharmacology.
Every now and then I like doing an experiment. Okay. Well, no, we did it in class.
Oh, wow.
Just like we're doing this in class.
I just posted it as a study guide.
So who knows? Maybe I'll go wild and just put this up as a test. I haven't printed it yet. I could do that. The store has clearance items that have been marked down by 60%. They're having a sale advertising an additional 30% off clearance items. What percent of the original price do you end up paying? Now, I'm not going to embarrass anybody by telling some of the answers I received that were wrong. There is a way to do this without any numbers at all, just using the percentages. I personally think it's a little beyond what we need to know in this course. So my method was, original price was $100. And I think we did this exact problem. Now I'm marking it down 60%. 60% of what? Of the 100. So 60% of 100 is 100 times 0.60, $60. So I'm marking it down $60. What's my price now? $40. 100 minus 60. So now my price is $40. And now I'm going to mark it down an extra 30%. 30% of what? 40. So times 0.30, 12. So now what do I do? That's a discount. Another discount. Subtract 12. So now my final price is $28. And now this is why I use 100. Because remember, percent is the part over the whole times 100. So in this case, my part is 28. My whole is 100 times 100. So what happens here? This and this cancel out, and I end up with 28%. And that's why I use 100 for the starting point. You can use 200, you can use 1,000, you can use $233.47 if you want. Just makes the math a lot harder. 100 makes it easy.
Test, like some of that is just no, like do you have to write it all out still, or are you okay? Like,
Here's the way I go with showing work. Theoretically, you could just write down the answers. But if you miss something and you don't write anything down but the answer, I can't give you any credit because I got nothing to give you credit for. Now, like if you did this and you got this and then you subtracted it from 60 and got 48, you get most of the points, probably 3 of the 5, because you made one minor error. So I'm not saying you have to. I don't count off if you don't, although it can get suspicious on some of these problems if you do that. I mean, would you write this on the test and show no work? That would get a little suspicious. But at this point right now, I trust that everybody's honest. Until you give me reason to think otherwise, I'll stick with that. Otherwise, I'll have to start coming up here with my binoculars. Or I can print out 28 different tests. There's only 28 of you in here. I could do that. Not a problem. Wouldn't take any more paper. Just change the number by 1 for each of you. All it'd take. A crepe recipe calls for 2 eggs, 1 cup of flour, and 1 cup of milk. How much flour would you need if you use 5 eggs? So 1 cup of flour, I use 2 eggs. I don't know how many cups of flour I use for 5 eggs. Or you could set it the other way. But you got to be sure you set it right. Got to be eggs and eggs on top, or eggs and eggs on bottom. Then we simply multiply, cross multiply. 5 equals 2x divided by 2x equals 2.5 cups. That's it. None of these problems were meant to be difficult. Yeah, 5 over 2 would work. Okay, now we have our car driving 100 kilometers per hour. How far does it travel in 2 seconds? And we're driving 100 kilometers in 1 hour. That's how this translates. Now, 1 hour has 60 minutes. And 1 minute has 60 seconds. And I want to know for 2 seconds. So the first thing we can look at is I have hour in the denominator and hour in the numerator, so those cancel each other out. Same here with minutes. And this is understood to be over 1. Same here with seconds. So now the only measurement that I'm left with is kilometers. Multiplying my numerators, I have 100 times 1 times 1 times 2. Multiplying my denominators, I have 1 times 60 times 60 times 1 of 200 over 3,600. And technically that would work. Some of you gave me 1 over 18 kilometers. That would probably be the best answer. That's the one I saw a lot of. 0.055 repeating, that would work. I probably wouldn't count off to that, but it's not precise. Some of you put it in meters, which would work too. What was it, 55.5 repeating? I'd accept that. So any questions on the problem solving homework? So now you see when you get home, you can take that sheet, upload it, and you're done with the homework. So on to statistics. There was a little bit of confusion on this one so far, not a whole lot. A political science surveys 28 of the current 106 representatives in a state's Congress. Of them, 14 said they were supporting a new education bill. 12 said they were not. I never said I could type. Supporting the bill, and 2 were undecided. So what is the population of this survey? What is the population of the survey? Not how many members are, how many people are in the population. Because that's the next question. That right there should have told you 106 was not correct for A. What is the population? The representatives. And that answer is a headache on the test because misspellings are saying members of Congress or representatives of Congress. It won't accept those. It counts it wrong and I have to go back and fix it, but that's okay. What is the sample size? How many? What is the sample statistic for the proportion of voters surveyed who said they were supporting the education bill? 14 out of 28. Right? Is that how many said? 14 of them out of the 28. Now, based on this sample, we might expect how many of the representatives to support the education bill? That is technically correct, but that's not what I'm looking for. We want to know how many, and that's correct, 53. I'd probably only take off a point for that. Yes.
Now, is that 53 out of the 106?
Yes.
Okay.
Because 14 of 28 is a half, and half of 106 is 53.
Okay.
The idea of a sample is to get a good enough sample that it represents the population so we can basically move those numbers. Not necessarily happens all the time, but that's the idea. In a study, you ask the subjects their age and years. Is this data qualitative or quantitative? Quantitative, because we can calculate an average age. In a study, you ask the subjects their gender. Is this data qualitative or quantitative? Qualitative. At least I haven't figured out a formula to figure out the average gender. So I'm going with qualitative. So that's statistics. Any questions on statistics? Stuff wasn't hard, was it? No? Yes, maybe. The teacher is trying to encourage her students to read more books. For the current 9 weeks period, students in her class read the following sorted number of books. So for this data, what is the mean number of books? So the mean is the sum of all the values over n. And I think n is 20, right? Anybody remember what the sum of them all is? I'm sorry, 126. over 20, which comes to what, 6.3? Again, if there's decimals, give me a 1 or 2 of them at least. I mean, if it comes out to even 6, that's fine. But if it comes out to 6.3 something, give me some decimals. What is the medium number read? Remember to calculate the median, we take n and divide it by 2. So we have 20 divided by 2, which is 10. And if we have a whole number, we take that data point plus the next one and divide by 2. We find the mean of the 2 data points. So I'm looking for the 10th and 11th. 3, 4, 5, 6, 7, 8, 9, 10, and 11. So it worked out nice. 7 plus 7 over 2 is 7. That's the median. Any questions on that? Everybody got it? The school basketball team posted the following sorted scores in 13 recent games. N equals 13. Find the mean score. What's this add up to? Does anybody remember? Is it 770 over 13? What would that come to? 59.23? Some of you have done it and you remember. Okay, so the median, again, we look at n divided by 2, which is 13 divided by 2, which is 6.5. If I have a decimal, no matter how small it is, I round up. So I'm looking for the 7th data point, which happens to be 56. 1, 2, 3, 4, 5, 6, 7. And then the modal score is the one that appears the most often, which is also 56. Any questions on that one? Okay, so let's write these in order, and I'm going to write them vertically. 10, 11, 13, 14, 14, 14, 17, and 99. Okay, so what's the mode? We got 1, 2, 3, 4, 5, 6, 7, 8. So n equals 8. The median is 8 over 2, which is 4. So I need the 4th and the 5th divided by 2. And both of those are 14. So I'm looking at 14 here. Anybody remember the sum? 192. To find my mean, I take the sum of x's over n, which is 192 over 8, which is 24. Okay. Now for the standard deviation. If you recall, the formula for a sample. Sample standard deviation is the square root of the sum of x minus x bar squared over n minus 1. So I need to find out what x minus x bar is. In other words, the data point minus the mean. Here we have negative 14, negative 13, negative 11, negative 10, negative 10, negative 10, negative 7, and positive 75. Now I need that squared. 196, 169, 121. Somebody do the last one for me. And then what's the sum? 6480?
60.
60. I was close. So I have my sum. I have n is 8, so n minus 1 is 7. So I'm looking at the square root of 6460 divided by 7. What was that? 922 and some change? Everybody remember how to do the square root? Put it on your calculator. Here I get 30.36. You remember how to do the square root? If you're lucky, you have a button like this that has that squared, and above it is a square root symbol. Where you hit the second button on some of these calculators. Another way to do it, 922, and you may have a caret on your calculator. You can do that to the 0.5 and you'll get the same result. I have a square root and a box. How did everything get so big suddenly? Won't let me move anything. Technology does not like me. Whatever I did, it's not going to let me undo it. Do I have any computer people?
That's a touch screen, can you just like shrink it down?
No. You can move that. Hey, it worked finally. I pushed it about 5 times. I was off the grid during the time that all the computer stuff changed drastically for like a 5-year period of time. 5-number summary. And yes, I know it's a pain to have to put these in order. Had them in order for everything else. Help me out. Don't let me miss something. 15. 22. I thought I saw 24 somewhere. 28. 29. Is there 30? Yep, 31 and 32. 36, 39. 42, 50, 52, and 62. How many do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. N equals 15. So, I highly recommend to build your confidence. Start with the easy ones. What's the minimum? What's the maximum? How do we find the median? We've already done some, so we should know that already. N divided by 2, right? 15 divided by 2, 7.5. If it's a decimal, no matter how small, we round up. So I want the 8th data point. 1, 2, 3, 4, 5, 6, 7, 8. 31. Okay. Now the location for Q1, 0.25. times n, which is 15, which is 3.75. Again, if it's a decimal, no matter how small, round up. I'm looking for the fourth data point, which is 22. Why did that come back? And then the locator for 3 is 0.75. And this is where a few people reverted back to standard rounding rules. Remember, no matter how small a decimal, in the case of finding a location, round up. Well, which is 42. I got a lot of 39s. Any questions on the describing data chapter? I'm sorry? No matter how small the decimal, when finding the location of Q1 and Q3, you always round up. Okay, ready for the next page? Last page. And again, formulas will be given to you. I believe it's the last page. Well, it has all its formulas. My recommendation is tear it off. I don't need it back, and you can use it for references. It's easy to refer to it on a test if you pull it off. The math department of a college has 12 male professors, 13 female professors, 7 male teaching assistants, and 9 female teaching assistants. If a person is selected at random from the group, find the probability that the selected person is a teaching assistant or a female. So probability, we have a TA or female. And if you look on your probability sheet that you'll have, this is the probability of a TA plus the probability of a female minus the probability of a female TA. So how many faculty members do we have? 12 plus 13 plus 7 plus 9 is 41. How many TAs do I have? 7 plus 9 is 16. So the probability of a TA is 16 over 41. How many female faculty members are there? 13 plus 9, 22. How many female, what's the probability of getting a female TA? Well, how many of them are there? 9? So 16 plus 22 is 38, minus 9 is 29, and they all have common denominators, so that's good. That's all I need. We prefer probability usually as fractions. Okay. You have a bowl containing 15 green marbles, 12 red marbles, 7 blue marbles, 6 white marbles. You draw a marble out of the bowl, check the color, and return it to the bowl. So we're talking about replacing it. You shake the bowl and then draw a second marble. Find the probability of getting a green marble the first time and a blue marble the second time. And I even added a little note here, not individually, but as one event. Because the probability when they're independent events of A and B is the probability of A times the probability of B. So what is the probability of getting a green marble? Well, how many marbles are there? You're 40, right? How many green ones are there? So 15 over 40. How many blue marbles are there? 7 out of 40. Multiply across 105, multiply across 1,600. That's all I need. And yes, I know it can be reduced. And many of you did. Doesn't have to be. Doesn't say to. Why take the risk of messing up? Okay, a restaurant offers a choice of 4 salads, 6 main courses, and 5 desserts. How many possible 3-course meals are there? Can I just have 3 desserts? What do we do to calculate this? Multiply. 4 times 6 times 5. 120 meals. Now comes the two that everybody gets backwards. A church has 8 bells in its tower. Now, first thing I'll say is, if you have 8 bells, they're all going to have different tones, right? Because if they all had the same tone, what's the point of having 8 bells? Before each church service, 4 bells are rung in sequence. No bell is rung more than once. How many sequences are there? So remember, on these problems, the question we have to ask ourselves is, does order matter? So does order matter? Got a 50-50 chance.
Yes.
Yes. Because playing the notes A, B, C, D is different than playing the notes D, C, B, A. So order matters. This thing is not cooperating with me today. I think it knows I was cheating on it. I used a different type of computer. So with order matters, what type of problem is it? A 50-50 chance. Permutations, very good. So the formula you will be given n factorial over n minus r factorial. So what I'm looking at here is I have 8 bells and I'm ringing 4 of them. So we have 8 factorial over 8 minus 4 factorial, 4, nope. Almost made that mistake. So I have 8 factorial over 4 factorial. 8 times 7 times 6 times 5 times 4 factorial. Right? This cancels out, and this is 1,680. Any questions on that one? So before we even read the problem, what's the next one going to be? Permutations or combinations? What do you think? Probably combination. So from 10 names on a ballot, a committee of 4 will be selected to attend a political national convention. How many different committees are possible? So yes, order does not matter. So we're looking at combination. And again, you will have the formula. N factorial over n minus r factorial, r factorial. So I'm looking at 10 choose 4. 10 factorial. 10 minus 4 factorial, 4 factorial. 10 factorial over 6 factorial, 4 factorial. 10 times 9 times 8 times 7 times 6 factorial over 6 factorial times 4 times 3 times 2 times 1. These cancel out. So you want to see a little trick of how we had to do it in the old days when we weren't allowed calculators? Of course, you could just multiply across the top and across the bottom, but there's a neat little trick you can do. 4 times 2 is 8. It gets rid of 8. 3 goes into 9, 3. Then I have 10 times 3 times 7, which I can probably do in my head. I have 3 times 7 is 21 times 10, 210. But you don't have to do it that way. You can just multiply across. But back in the dark ages, we had to do it that way. Any questions on permutations, combinations? Typically on an exam, if you get them backwards, I give you 2 of the 5 points anyway. If you do them right and you get them backwards, I probably give you at least 2. If you try a problem and do something that's somewhat reasonable, you'll get 1 out of 5. So just trying every problem, you're going to get a 20%. It's a good start. Good reason not to skip a problem completely. Last one. I have fun with this one on the test. It gets so funny. In 1999, the stock market took big swings up and down. A survey of 981 adult investors asked how often they tracked their portfolio. Table shows the investor responses. What is the probability that an adult investor tracks his or her portfolio monthly? Yeah. Now, here's the problem. Here's the thing that I see quite a bit on exams. As I said, the exams come from the homework. So quite frequently, it's the exact same words in different numbers. So some people, they see the words and they don't bother reading the numbers and they just hit the answer. A lot of the times I'll change it. Maybe I'll say weekly on the test instead of monthly. Maybe I'll say 792 instead of 981. Some people just, it's ingrained in their brain and they just give me the same answer because they're not registering that it's different. So be careful. Read the question. Read it twice if you have to. Make sure you're answering what I'm asking. Difficult today.